Today we're here to talk about envelope encryption, or the encryption of payloads in messaging and streaming systems as an alternative to the claim check model. So when we moved to the cloud, prior to moving to the cloud, people had no problems about putting sensitive or other data in their message queues or in their data streams in their on-prem data centers. When we moved to the cloud, everybody got very paranoid about the fact that their data might be in the clear somewhere in a data center that's essentially owned by another company. And so people mandated encryption at rest and encryption in transit. And one of the areas where this kind of broke down, or that we didn't have a really good answer, was for messaging and streaming. And so a lot of people have looked at alternatives like the claim check model, where you basically just put a claim check in and you call back to a service to pick up data, and that way there's no sensitive data in your messages or streams. There's a lot of cases where that doesn't work. I'll probably do a different talk on it. So let's assume that you have decided that the only way to make your system work reasonably is to, either for performance or other reasons, is to encrypt the data in your payloads, in your messaging or streaming. And so there's really two major approaches to this. And the first one is probably the one you would come to off the top of your mind. And that's basically, so if you're in a cloud, they always have a cloud provider store, and they have a cloud provider key store, and they have a cloud provider API. So if we were to look at those, the first thing you might do is you might say, hey, my producer is basically gonna do an encrypt call to the cloud service. The cloud service is gonna get the key. It's gonna encrypt the payload, and then we're gonna send the payload, encrypted payload, into the message store of the stream. When the consumer receives it, it's gonna call the cloud decryption service, and that's gonna get the key from the secret store, and it'll return the decrypted data, and we're good to go. And so the beauty about this approach is the cloud actually manages access to the keys, so you don't have to build your own key store, and you don't have to manage access to it, write your own access controls. You can just use the cloud provider, and this works in Azure and in AWS. It probably works in Google too, but does anybody know what happens in Google anymore? So if we were to, oh God, I hope I don't apply for a job for them and they see this video. All right, so anyway, so that's probably the main approach. But it turns out that asymmetric encryption keys, they're kind of expensive to use, right? And they also, a lot of the encryption services don't work for data over a certain size, like 4K or something like that. So the alternative is to use data key encryption, or encryption using data keys, which would be a second set of keys. So the basic idea to this, I'm going to look at my blog article here I wrote, and I'll put the link in below. And basically the idea is you can do this kind of envelope encryption using data keys. And so what you do is you create a symmetric encryption key, you encrypt the data with that symmetric data key, and then you encrypt the data key with your asymmetric cloud key, and you send the encrypted data key and the encrypted data in the message. And so the reason you would there's a couple reasons you would do this, right? It turns out that if you do this envelope or data key encryption, that it's a lot faster. So the asymmetrical algorithms are slower. They generate larger data. They're more expensive, and you pay for the call on the cloud provider based on kind of how many calls you do or how much data you're passing. If you were to go with the envelope route, what can happen is you can use these symmetric keys to actually encrypt and decrypt your data. And when you send the key along, you actually don't have to manage the second key because it'll actually come as part of the payload. And you only call the cloud provider to encrypt and decrypt these data keys. If you don't rotate the keys very often, like maybe hourly or daily, you can actually cache those keys, in which case you won't actually be making as many calls to your cloud provider. So that's all really confusing. So I did this drawing here that we'll walk through for the next couple minutes. So the idea here, so the SDKs by Amazon and Microsoft both already support this. So this looks like a complicated diagram, but basically the SDK is going to manage a lot of this for you. So the producer basically makes a call to the SDK to encrypt the data. The SDK, if it doesn't have one, so for the Amazon one, it'll create it and cache it. And for the Azure, I think you have a choice of whether, I don't know if you can cache it, but you can create it, or you can actually cause it to create a new one each time. The SDK will then encrypt the data key using the cloud provider, so it's only going to encrypt a small string. And then it will encrypt the payload using the unencrypted data key. So the black keys here represent symmetric encryption or encryption keys, and the green ones represent asymmetric. When the SDK is done encrypting the payload, it will basically, what you do is you send a message to the data store or the streaming system, and you send the payload encrypted with which would be encrypted with the symmetric key, and you send the data key, which is encrypted with the asymmetric key. So you send an envelope, and then you send kind of a key to it, and then when it arrives on the other, it goes into the message store. The consumer pulls out the message, which has the payload encrypted with the symmetric key, and the key itself encrypted with the asymmetric key. And like I said, the SDKs, you can set the rotation rate on these, and you can also set the caching behavior. So you can dramatically reduce the number of calls, or you can not reduce the number of calls, but you still get the speed of symmetric keys, right? And you get the security of rotating them all the time, so that even if somebody were to pop open a message and actually see one of the keys, they wouldn't be able to do anything with the other messages with it. So when the consumer receives the message, it's going to call the SDK to decrypt the payload with the data key. And remember, the payload is encrypted with the symmetric key by the SDK on the other side, and the data key was encrypted by the cloud service by the SDK on the other side. The SDK will then call the cloud service to decrypt the data key, and it will decrypt the payload using the data key that came in the payload that was decrypted by the key store service, and then you will get a decrypted payload back. All right? If caching is enabled, this creating the data key and encrypting the data key step is skipped on this side, because you will reuse the data key and the encrypted data key for some period of time, your choice. And then also, if you did the caching and you reused the keys, so it's caching and the keys were reused for some period of time, then you really wouldn't have to make this call either. So step 2, step 3, and step 8 are dropped, and you still get the high performance of symmetric encryption for your data, and you get the security of pretty regular key rotation. So that's it. I wanted to keep this kind of short. I don't know if that's kind of crazy. We'll see you another time. Bye.